Okay, again, good morning. So for module 3 in second quarter of Earth Science, we'll be discussing crustal deformation. So the formation of folds and faults as well as the effects of stresses to rocks. Okay, so let us begin. So we start by defining deformation of rocks, diba? So deformation, as based on our resources, is all the changes that will occur to a rock when um, it experiences stress. Okay, it can be a change in shape, it can be change in size, change in volume, or change in orientation. Okay, so the rock that you can observe here, as you can see, um, medyo ano na siya, very unique na yung kanyang itsura because it changed in a lot of aspects, no? It changed in its size, its shape, as its orientation. Yung volume niya pwedeng nabawasan din siya or pwedeng mag-increase siya. Okay? So, deformation actually has three components. Okay, when we look at deformation in general, we can observe that it has three components. One is displacement. So basically, displacement occurs when um, a rock, let's say it produced a joint or a fault kapag yung kanyang pagbabago nag-involve din ng movement nung isang block. Okay? It's either yung isang half ay gumalaw or yung isang half yung gumalaw or both of them moved. Okay? So rotation on the other hand is um, yung pag-tilt ng rock. So with respect to an axis, so let's say with respect to a certain axis, um, yung rock natin magbago yung orientation niya. So hindi siya originally, let's say, nakaslant, pero dahil nagkaroon ng stresses or nagkaroon ng mga, yun nga, nagkaroon ng involvement of different types of stress, nag-tilt yung rock natin. Okay? So distortion on the other hand is yung pagbabago niya nung shape. Okay, so pag nagkaroon siya nung like yung pag-wave niya or yung pag-produce niya ng parang undulate, so yun nga, parang wave-like appearances. So we can consider that as distortion. Okay, so pwedeng combination, yung deformation in general can be a combination of these three components. Pwedeng isa lang dito, pwedeng dalawa lang dito, and such. Okay, so pwedeng iba-iba yung combinations niya. Okay, so let's look at this example here. And can you tell me, guys, if this formation of rocks here is considered as deformed or undeformed? So we have here a sandstone. Can you guys tell me if this is considered as a deformed rock or a undeformed rock? What do you guys think? Is this a deformed or undeformed rock? Based on our the description. Anyone? Is this deformed or undeformed? Anyone? What can you observe in the layers? In the shape of these layers? What do you think, guys? Any guesses? So you have a 50% chance to guess it right. Is this deformed or undeformed? Hello?
Deformed, sir.
Okay, sabi ni Marco, deformed. How about the others? Sige, let's have another one.
Deformed.
Okay, sabi ni Claire, deformed. Deformed. Okay, almost all of you answered deformed, but this is actually undeformed. So, if you can see, or if you guys can observe, sorry, um, yung layers ng rock natin ay very ano pa siya, tuwid pa siya or horizontal pa yung placement niya. So, wala pa masyadong significant change na nangyayari dun sa rock layers natin. And kung titingnan din natin yung grains niya, okay, these are, di ba, normal grains. Kasi remember, di ba, when rocks undergo changes, yung grains din nila pwede magbago, yung mga mineral grains na yan. So makikita natin, spherical pa sila, wala masyadong changes. But if these grains actually experience stress, pwedeng mag-elongate yung shape nila or pwedeng mag-flatten sila, di ba? So as we learned in our previous discussion. So this is actually an undeformed rock formation. How about for this one? Is this deformed or undeformed?
Deformed, sir.
Very good. Okay, so this one here, that is correct. This is a deformed rock. Okay, ito na yung mga deformed rock formations natin. So kung mapapansin nyo, yung layers ng rocks natin, for example, this example here for quartzite and slate, ano na siya, wave-like na yung appearance niya. So nagkaroon na siya ng ano yung isa? Distortion. Nagkaroon na ng distortion yung mga rocks natin. So kung titignan nyo din yung grains, um, meron na tayong kung titignan nyo yung grains dito, mapapansin nyo, siya ay ano na, naka teardrop na shape na siya. Medyo na-stretch na siya, oval-like na. So, we can conclude that these grains here, 'di ba, parang kumbaga microscopically makikita natin na naka-experience na ng stress 'yan. And kung titingnan din natin yung layers, kung nakita natin yung layers na nakaganyan, yung i-cross section natin siya, um nag-experience na siya ng stress kasi we can clearly see the distortions in the layers of the rocks. Okay? So, this is deformed. How about this one here? Oh, medyo nakita na ata yan kanina. This one here. Deformed, undeformed. This is deformed. Very good. Can you guys tell me kung ano yung deformation na nangyari dyan? Anong change na nangyari dun sa bato natin dyan? It changed in, di ba tatlo yung components natin? Etong, very good. Very good. It's rotation. So, nagkaroon ng pag-tilt doon sa ating rock. Okay? Very good. How about this one? Okay, based on our example earlier, dun sa sandstone, do you think this one is deformed or undeformed?
Undeformed, sir.
Very good. Undeformed. So, kung titignan natin siya and based on the example earlier about the sandstone, we can clearly see no that the layers are horizontal. So, um, masasabi natin no that the stress is not enough to change these rocks na nahanap dito. Okay? So horizontal layers, uniform pa sila in appearance. So usually yon. Ganun yung ating conclusion. Okay? Okay. So let's move on defining stresses and strains. So na-define na natin yung deformation as the change of a rock. Okay, the change of a rock in its rotation or kung sa kanya nagkaroon man ng displacement, nagkaroon man ng distortion. So any change na nangyari dun sa rock in terms of its sorry, shape, its structure, and volume and such, no? So kung ano man yung mga changes doon na nangyari, we call that as deformation. But what brings these changes ba? Ano ba yung mga nag-cause nitong changes na to? And when talking about deformation in rocks, we talk about stresses. Okay? So kaya nagbabago ang rock ng kanyang orientation, kaya nagbabago ang rock um, ng kanyang itsura in general is because of stresses. And stress, as we define in geology, is the force per unit area. So, parang, technically speaking, 'di ba, parang yun nga, force naman talaga siya kasi, um, itong mga rocks na 'to or itong mga bato na 'to, they are subjected to different types of forces naman talaga. But in general, yung stress na tinutukoy natin dito is force per unit area and this is the cause. Okay? So ito yung tinutukoy nating cause. Ano yung nagbe-bring nung changes na yon, nung mga yun, nung mga pagbabagong yon, and that is the stress. Okay? So para visualize natin siya. So yung stress kasi parang kung iisipin nating mabuti, parang the more the stress, supposedly, parang the more the stress, the more changes it can bring dun sa rock na yon. But kailangan i-consider din natin actually yung area na kung saan nag-act yung stress na yon, okay? Or yung force na yon. Is it evenly distributed or nag-a-act lang ba siya sa single point? So ang magandang example dito, and feeling ko sa mga magic, sa mga nagma-magic or sa mga nagagawa ng mga tricks, parang applicable din 'to. So 'di ba yung ito yung example diyan, yung if you step a can, on a cola can, 'pag tinep mo siya na isa lang siya, so you bring your full weight to that can, automatically talaga magka-crush siya, 'no? So makikita talaga natin na magde-deform yung mismong can. But if we stand, let's say, on yung madaming cans, so mag-lay down tayo ng madaming cans, let's say 50 or 100 cans, and then tumapak ka do'n, okay? Maglagay ka ng wooden board, then tapakan mo 'yun. So hindi easily magka-crush yung cans na 'yan, 'no? Or rather hindi siya magka-crush talaga because yung force evenly distributed dun sa cans, 'di ba? So evenly distributed siya dun sa area. And yung rocks natin, nagfo-follow din siya ng same principle, no? So if stress is applied on a single point, mas magkakaroon ng changes, mas magkakaroon ng mga deformations or strains. But if mas evenly distributed yung force, mas mahirap. Mas mahirap i-deform yung rock natin. Okay? So again, that is for the stress. Force per unit area, and this is the main cause. Okay? It is the main cause. So, yung stress na tinutukoy dito sa modules nyo and sa geology in general, um, it has two types. Okay? So, one is called the normal stress and the second one is called a shear stress. Pero itong normal stress, it is further divided into compression and tension. Okay? So, in general, pag sinabi nating normal stress, it is simply yung stress, the stress that is applied is nasa right angle siya ng surface nung bato natin or surface ng any object. Okay? So, normal stress, again, this is the stress applied, kumbaga, on a right angle with respect to the surface. Okay? So, it can be compression and tension. Compression kapag um, yung direction ay nagmi-meet together, nagmi-meet sila sa middle, parang yun nga, kino-compress nila. That's why yung usual na naging effect niya is yung gitna parang mas nag-thicken siya. Yung tension naman, on the other hand, opposite yung directions nung stress. Magkapahiwalay sila ng direction. So, nag-thin down yung middle. Okay? Yung shear stress naman, kung yung normal stress, e.g. yung compression and tension ay at a right angle sa surface, yung shear stress naman ay parallel dun sa surface. Okay? So, itong mga stresses na to, again, ito yung mga causes nung pagbabago ng rocks natin, ng mga deformations ng rocks natin. But yung actual na change or yung actual na deformations, those are what we call strains. Okay, so mamaya malalaman natin yung mga different kinds of strains, yung mga elastic, inelastic, and such. Okay, so pag nagkaroon na ng change dun sa rock natin, nagkaroon na ng change in shape, ng size, ng orientation, and such, yun na yung tinutukoy na strain. Okay, so kapag ang rock ay naka-experience ng stress, pwedeng makapagdulot yun ng strain doon sa rock natin. So, in turn, if stress is the cause, then strain would be the effect. Okay? What would be the effect of compression stress? What would be the effect of shear stress on a rock and such? Okay? So, hindi naman independent yung mga stresses na yon. 'Di ba? Yun nga, may iba't ibang type ng stresses, but in reality, itong mga stresses na to can act ng sabay-sabay. Kumbaga parang hindi lang pwedeng isa lang yung mangyari. Pwedeng hindi sabay-sabay, pero pwedeng yung bato natin dumaan siya sa sa iba't ibang stresses. So, halimbawa, for example, yung first stress niya ay shear stress, and then after a while, biglang naka-experience siya ng compression, after a while, tension, tas compression ulit, and such. So, makikita naman yun dun sa mga bato. Okay, so yun nga, nasabi ko na to, normal versus shear stress. Again, right angle yung normal. Right angle with respect to the surface. Shear stress naman is parallel to the surface. Okay? So compression and tension. So kung mapapansin nyo, compression, yung directions niya, 'di ba? Um, Same ba 'to? Parang masasabi ba nating same 'to? O basta para sabihin na lang natin na gano'n, same direction siya, and yung kung mapapansin niyo yung gitna niya, mas magfi-thicken talaga, okay? Mas nagfi-thicken yung gitna niya. So, eto daw usually compression is observed yung 'yan when tectonic plates collide, or yung mga tinatawag nating collision plate boundaries. 'Pag tension naman, ito yung stretching. So, opposite directions yung ating stresses, opposite direction sila, and mas nagfi-thin down yung middle natin. So, mas manipis yung middle natin. When a continent begins to break apart, or yung divergent plate boundaries. Etong shear stress naman, parallel nga siya sa surface. Ano? So, parallel to the surface, kung papansin nyo. Yan. So, usually daw, it happens at transform plate boundaries. Okay, so yung pag-slide ng mga plates na yun. Okay? Okay. So, usually, yun nga, gaya ng sabi ko sa inyo kanina, yung stresses na pwedeng ma-feel ng isang bato, hindi lang independent na iisang stress lang. So, possible na multiple yung stress na feel niya. For example, let's say itong darker brown na area. So, ito yung rock na tinitignan natin. For example, siya ay nahanap sa divergent plate boundaries. So, may paghihiwalay ng mga plates, nagkakaroon ng tension. So, napupull apart yung ating bato. But at the same time, it is subjected din sa um, stresses na binibigay ng mga layers of rock na above at below doon sa bato natin. So, meron ding compression na nag-o-occur at this level. So, mapapansin natin, hindi independent yung, independent stresses sila. But what I mean is, yung both stresses ay nag-act upon doon sa bato natin ng sabay. Okay? So, pwede yun. Okay. So, ito yung mga tinutukoy naman nating strain. So, kung yung stresses, sila yung causes ng mga pagbabago, yung strain yung mismong pagbabago nila. Ano ba yung mga iba't ibang changes na nag-o-occur sa rock? Paano ba natin sila kina-classify? So, simply, we can classify the changes into two things, elastic versus inelastic. Okay, so elastic, if the change is elastic or the strain is elastic, ang ibig sabihin lang nun, magbabago yung shape, magbabago yung kanyang size, magbabago yung kanyang volume, pwede din. So magbabago yung mga ganong bagay, yung um in general, shape and size niya magbabago. But after a while, pwedeng bumalik ulit sa original shape yung rock natin. So yun yung tinutukoy natin na elastic. Okay? So once yung rock natin siya ay um, nag-experience ng stress. Okay? So nagkaroon ng pagbabago sa kanyang itsura in general, pero bumalik ulit siya dun sa original na form niya, we consider that as elastic. Okay? So the strain is elastic. So isang example Um, Ayan, yung isang example dito is sa dough. So, yung dough 'pag naka-experience siya ng, stress, flinatin natin siya, um, single piece pa rin 'no, so it still remains as a single piece. I think this is for ductile pala. I think this example is for ductile, I'm sorry. So for elastic, ang isang example usually natin diyan is rubber pala. So sa elastic 'di ba rubber, even if you stretch it, babalik at babalik pa rin siya dun sa original shape niya. Unless you reach yung tinatawag na parang elastic limit, at which point parang magbabago na ata talaga yung, shape or general na appearance nung bagay o nung material. Okay? So, yun yung elastic. So, pag sinabi nating inelastic, ito na yung changes na hindi nababalik sa original na form niya. So, elastic, magbabago siya pero babalik siya sa original form niya. Sa inelastic, magbabago siya pero definite na yon. Hindi na siya babalik dun sa original form niya. And we have two types of inelastic strains, okay? Ductile versus brittle. Kapag ductile, ibig sabihin nito is nagbabago yung shape and size niya, but hindi siya nagfa-fracture or hindi siya nagfo-form into different, hindi siya nagka-crack into different fragments. Okay, ductile. Ibig sabihin single piece pa rin yung rock natin, pero nagbago siya ng nagbago siya ng form, ng shape, ng whatever. Okay, pero single piece pa rin siya. So yung example nga dyan is yung dough natin. Once we flatten it using a book, for example, yung dough, hindi naman siya nag-fragment into different pieces, but instead, nag-flatten lang siya into a single coherent piece. Okay, so nag-flatten lang siya, but it's still in one piece. Pag sinabi nating brittle, yung strain, or pag sinabi nating brittle, yung deformation na mag-occur, nagka-fragment siya or it separates into distinct fragments. Nagkakaroon siya ng mga distinct na cracks or mga parang fissures or joints. Yun yung brittle na deformation. Okay, so yun yung pinakaiba ng dalawa, ductile versus brittle. Actually, share ko lang din dito sa elastic. So kung isipin natin mabuti no, so yung rocks pala, they have the ability na bumalik pa rin sa original shape nila. So minsan actually ang nangyayari, yung mga rocks sa ilalim ng lupa, usually yun sa mga malalalim, um, usually nag-undergo sila ng mga elastic na strains, elastic changes. Kaya once na bumalik sila sa original shape nila, pag biglaan silang bumalik sa original shape nila, nagkakaroon yun na rebound. Nakalimutan ko yung tawag. I think it's called an elastic rebound. And sometimes yung rebound na yun nagko-cause ng pag-produce ng waves, ng energy waves in the form of earthquakes. So sometimes yung yung elastic rebound, nagiging cause din siya ng earthquakes. Okay? Okay. So eto, I don't think this is nasama siya. I think nabanggit lang siya sa module. But I think it's important na i-consider din natin or i-discuss natin to sa pag-uusap ng mga stresses, okay, and deformation, because there are actually several factors which affect the deformation o yung pagbabago ng bato natin. So 'di ba nasasabi natin yung mga stresses in general, yung mga types nila and yung mga types ng strains nila. Pero kung in reality kasi, yung mga stresses na yun, iba-iba sila ng effect sa um, iba't ibang types din ng bato. Okay? At the same time, yung time, kung gaano sila katagal na experience ng bato, factor din yon para dun sa deformation ng rock natin. Okay? So, yung mga ganong bagay, consider din natin. So, ano nga ba yung mga factors na nakaka-affect sa isang bato, okay, para sa kanyang deformation o yung pagbabago ng shape and size niya? So, isang factor is composition. Okay? So, sa composition daw, if mas strong yung internal molecular bonds niya, meaning may mga crystalline structure siya, may mga lattices, mas brittle yung strain na mag-o-occur dun sa bato na yon. Okay? So in general or generally speaking, if a rock is composed of crystals or lattices or mas strong yung internal molecular bonds niya, ang strain na mangyayari sa kanya usually ay brittle or inelastic. Okay? Kapag naman weakly cemented siya, okay? Or may mga zones of weaknesses siya. So this is mostly observed in sedimentary rocks. If it is weakly cemented or siya ay, yun nga, may mga zones of weaknesses, may mga pores, cracks, joints, fissures, ductile yung change niya. Okay, so usually ductile yung change or ductile yung deformation niya. Okay, so pagbabago ng shape and size but and still in a single piece. Hindi siya nagfa-fragment. Okay? What else? So, time, again, yung time, malaking factor din siya because if it is slowly applied, if the forces or the stresses are slowly applied or over time siya doon sa bato natin, taon yung binibilang, okay? Usually, ductile yung magiging response, okay? Usually, yung change ay magiging ductile. Hindi siya nagfa-fragment, hindi siya nagfa-fracture, but instead, parang it's still a single piece pero nagbabago yung kanyang shape and size. Kapag naman sudden yung forces, sudden yung pagbabago or pag-increase ng forces na yon, ang usual na response ng rock ay magkaroon ng brittle na deformation. So nagfa-fragment siya or nagka-crack siya, nagpo-form siya ng several pieces. Okay? Okay, so another factor na i-consider natin and actually a big factor is temperature and pressure. Okay? So usually okay, usually pag titingnan natin dito sa graph, may tinatawag tayong brittle ductile transition zone. Kasi um nawala po ba yung presentation?
Hindi po, sir.
Hmm, okay.
Okay naman po, sir.
Nakikita ba yung brittle ductile transition zone tas may graph?
Opo, sir.
Opo,
Nakikita
sir.
po.
Okay, okay. Okay. So dito, yung tinatawag na brittle ductile transition zone kasi usually ang mga bato talaga nagkakaroon, pwede siyang magbago from usually ductile to brittle. Ganun yung changes na nangyari sa kanya. So actually pwede muna elastic, okay? Opo, ma'am, baka po na ano niyo po na sa iba niyo po na focus, ma'am, yung ano, yung Zoom po. So usually ang rocks na yung changes niya usually from elastic to inelastic. So yung pattern usually na fina-follow niya, magkakaroon ng elastic changes and then at a certain point of temperature and pressure, magkakaroon ng ductile na change and then at a certain temperature at a certain point in temperature and pressure ulit, magkakaroon ng brittle change. So usually nagka-transition siya from elastic to ductile to brittle. So pagdating sa brittle and ductile, may tinatawag tayong brittle ductile transition zone to which ito yung point. Okay, this is the point in at both temperature and pressure to which magta-transition yung change niya from ductile to brittle na deformation. Okay? So may tinutukoy tayong brittle and ductile transition zone. So kapag iba din yung stress, kung papansin nyo, kapag iba din yung stress, nagbabago din actually yung brittle ductile transition zone. Okay? So tignan muna natin. So usually kasi 'di ba, as we go along as we discuss in Earthsci, ang pressure at ang temperature ay laging function lang din siya ng depth. Usually laging gano'n. Pag palalim ng palalim, pataas ng pataas yung pressure, pataas din ng pataas yung temperature. So kung mapapansin niyo dito sa tension, pag yung stress na na-apply dun sa rock ay tension, anong mapapansin niyo dun sa brittle ductile transition zone? So dito sa brittle sa pag-tension yung stress na ina-apply, yung changes na for ductile, usually siya ay nahanap sa mas mataas na temperatures. Okay? Mas mataas na temperatures or mas mataas na pressure. Okay, laging ganon. Mataas temperature, mataas temperature, mataas pressure. So usually nandun yung ductile na part while yung brittle ay mas mababang areas. Okay, pag tension. Pag naman siya ay nasa compression, mas maliit yung pressure na needed for ductile deformation to occur. So kahit mababang pressure lang, pag compression yung stress na present dun sa rock, mas favored niya yung ductile. Okay, mas favored yung ductile. So kung papansin nyo, yung transition zone, medyo nandun lang din siya sa mas mababang pressure. Okay? Dito naman sa tension, pag tension yung ano niya, parang ano ba yung term doon? Parang proportional yung atmosphere to temperature. Okay? So yun yung relationship niya pag sa tension. So sa compression, mas iba. Okay lang po, Miss Erica. No problem po. Okay. Ayun. So like I said a while ago, usually ang rock ay nag-undergo muna yan ng elastic na change. Tapos at a certain point, ayun, tama nga yung term natin, at a certain point, pag na-reach na yung elastic limit, mag-undergo na siya ng inelastic. So at this point here, sorry, ang pangit. Wait lang. At this point here, point Z, magkakaroon na ng inelastic change doon sa ating bato. Okay, magkakaroon na ng inelastic change dun sa rock natin. And usually, the first change that will occur is a ductile deformation. Okay, so at around point Z, okay, the range between point Z, this range here, point Z to yung value before F, yan yung ductile change. Kasi at point F, mapapansin nyo, mag-experience na siya ng fracture. So pag nag-experience na siya ng fracture, ano po yung deformation na mag-occur dito? Anong deformation na po yung mag-occur? Once na-experience nyo na yung fracture. Yung?
Fault.
So after ductile, ano na po yun? Mag-occur. Very good.
Brittle po.
Okay, very good. Brittle. So pag nagkaroon na ng fracture, magkakaroon na ng brittle deformation. Okay, so usually nandun na talaga siya sa latter end ng strains. Okay? Okay, so let's now move to yung iba't ibang deformation na nag-occur sa mga rocks due to either brittle or ano yung isa? Brittle or ductile na pagbabago. Okay, so pag pinag-usapan yung brittle deformations, ang first thing na papasok sa atin ay yung faults o yung formation ng faults. Thank you din po, ma'am. Usually yung formation ng faults. Pero actually may isa pa, joints and veins ay considered din as under brittle deformations. But i-discuss lang muna natin tong joints. Define lang din natin siya. So joints, kapag yung fracture ay walang movement sa either sides ng bato. Okay? So usually kasi 'di ba, kapag nag-crack na ang isang bato or nagkaroon siya ng fracture, magkakaroon ng distinct na sides. May left and right side. Okay? Let's say ganun na lang siya, left and right side. So kapag walang movement on either side, mako-consider natin siya as a joint. Okay? So yung deformation na yon o yung fracture na yon, we can consider that as a joint. Okay? Kapag naman fault, yung tinutukoy, yung fracture, yung isang side niya ay nag-shift or nag-move relative to the other side. So kung sa joints walang movement, sa faults merong involved na movement. Okay? So yung fracture ay may involved na movement. So dito sa joints usually tension yung present na stress. Dito naman sa faults either tension, compression or shear. Okay? Pwedeng yung tatlong 'yon. Okay? So again, joints walang movement, for fracture ay merong movement. And both, since napag-usapan na yata natin no na nag-occur siya or nangyayari yung fractures in two distinct sides. So magkakaroon ka ng two distinct sides. Usually kinaka-characterize din yung dalawang to as planar structures. And when describing yung planar structures, ginagamit yan ng mga geologists to to define yung orientation nung joint or nung fault natin. So, importante daw kasi na nade-determine yung orientation ng fault o kung paano siya, yun nga, paano yung orientation niya because gusto natin malaman yung um, kung paano yung mga possible na movement niya, no? So, pag pinag-uusapan yung mga faults, importante na kino-consider natin yung orientation niya kasi hindi natin alam kung hanggang saan ba siya, pumapailalim ba siya dito or nakaangat ba siya dito or paano ba yung magiging movement niya with respect to this plate. So, importante yung mga ganong bagay, di ba? Kasi gusto natin malaman, gusto natin mapaghandaan, lalo na kapag magkakaroon ng earthquake or ng movement ng any faults. Okay? So, when defining yung orientation daw ng isang um, joint or ng isang fault, sige, mag-focus na tayo sa fault. When defining yung orientation niya, we can define it in two in two aspects daw. Yung sinasabi nating strike and yung sinasabi nating dip. The strike is the angle between an imaginary horizontal line, the strike line, on the plane and the direction to the true north. So basically, parang yung angle na to, okay, this angle right here, this is formed from ito yung strike line or a horizontal line that I think this is parallel to the surface ng ocean ba or something like that. Di ko masyado maintindihan to guys eh. Basta yung strike basically is an angle that is parallel to ano bang tawag dito? That is parallel to a horizontal plane. I think ganun yung idea about this. So, the angle that is formed from the horizontal plane. Etong strike line kasi parang ganun yan eh. Horizontal line na, yun nga, nandun lang din siya sa mismong plane na yon sa horizontal na plane. So, the strike is simply that angle between yung north, direction of the north, and yung line na nahanap mo dun sa imaginary horizontal plane mo o yung horizontal plane. I think that horizontal plane is parallel to yung sea floor or something like that. Something related to the sea. I think surface or nakalimutan ko na sorry. So yon, with respect to the north, direction of the north, yung angle na yun yung tinutukoy na strike. While yung dip naman, on the other hand, the dip is the angle between a horizontal plane again and the dip line, an imaginary line parallel to the steepest slope on the structure. So ito naman involve yung um, slope or yung pinaka matarik na slope dun sa structure. Kung ano yung highest or yung steepest na slope dun sa structure, yun yung i-consider mo dun. So, as measured in a vertical plane perpendicular to the strike. So, sabi yung kung paano mo siya mame-measure is perpendicular doon sa strike. So, eto siya. Ito yung magiging ano niya, magiging angle niya. Okay? So, di ko din siya masyado maintindihan. Don't worry. Huwag nyo lang i-stress. Basta, dinefine ko lang din siya para at least alam natin kung ano ba talaga yung pinanggalingan ng strike and nung dip. Pero mamaya din kasi papasok po to um, sa movement nung or type ng fault, I think. Kasi yung dip, slip, and yung strike something ay inaano siya, dinedefine siya as yung movement niya relative to the dip and the strike lines. Ayun, dito nga yun. So yung faults, may iba't ibang movement na pwedeng mag-occur pagdating sa faults. Okay? Pwedeng siya ay dip slip or strike dip slip or strike slip. Okay? So etong dip slip, the movement is parallel to the dip. Okay? So yung dip natin kanina, 'di ba? It is the angle between a horizontal plane and the dip line as measured in a vertical plane perpendicular to the strike. So basically, with respect sa strike, yung angle that is measured perpendicular to the dip line, parang ganun yung idea. So kung titignan natin dito sa dip slip, pwede siya magkaroon ng tinatawag na normal and reverse na fault. Okay? So yung dip slip may two types pa siya, normal and reverse na fault. Okay? So sa dip slip, ang movement niya lagi, it's either parang pataas pababa. Okay? So if this is our fault, titignan mo natin. Okay? So kung dyan nag-occur yung fault natin, yung immediately above, the rock that is immediately above the fault is called the, oh my gosh, nakalimutan ko siya. It is called the, wait lang. Version ko. Okay, so the immediate one, yung immediately above dun sa fault natin is called the hanging wall block. Hanging wall block. Okay? HWB, the hanging wall block. So, yung immediately above the fault, okay, immediately above the fault is called the hanging wall block, while the one below is called the foot wall block. Okay? So, yung movement ng dalawang yan, usually kapag pag normal yung na-experience, yung normal na fault, yung na-observe, ang movement niyan ay tension. So yung stress niya ay tension, pahiwalay. And this is usually characterized by the lengthening of the crust. Kasi nga pahiwalay siya. So parang sinistretch mo, parang pinapahaba mo lalo yung crust. So pag normal yung fault, usually yun yung characteristic niya. Tension as well as lengthening of the crust. So yung movement ng hanging wall block, usually pababa yan, pababa. Tapos itong front wall block ay pataas. Okay, so paganon siya. Parang may imagine mo parang paganon yung movement niya. Kapag naman siya ay reverse, okay? Pag reverse yung fault na na-observe dito, so under pa rin to ng dip slip compression naman yung stress na nag-occur. So compression. Kung dito tension sa normal, dito sa reverse compression. Therefore, yung hanging wall block, ang movement niya ay ang hanging wall block, ang movement niya ay pataas. Okay, pataas, parang pinupush siya pataas. Tapos itong front wall block naman ay pababa. Okay? So yun sa ating dip slip fault. Okay, so sa dip slip fault, the movement is parallel to the dip. There are two types, normal and reverse faults. Kapag normal, usually characterized by tension stress and lengthening of the crust. The movement of the hanging wall block is downwards. Tapos opposite naman yung front wall block. Kapag naman reverse, okay, reverse fault, it is usually characterized by the shortening of the crust and the movement of the hanging wall block is above, okay, pataas. Okay. Okay, so dito naman sa strike slip, so kung kanina yung dip slip ay parallel to the dip, etong strike slip naman ay parallel to the strike. And 'di ba kanina dinedefine yung strike as yung nasa horizontal na plane siya, 'di ba? Parang yun yung idea about the strike. Horizontal yung plane na fina-follow niya as compared dun sa dip na mini-measure siya perpendicular to the strike. So wala siya dun sa horizontal na plane. Parang ganun yung idea. Dito sa strike slip, parallel to the strike. So, ibig sabihin, parang pa-side yung movements niya. So, with respect to a horizontal, yung movement niya ay parallel to that. Okay? So, parallel yung movement niya. Pa-sideways. Okay? So, yan yung pinaka-example niya. Makikita mo dito, no? That um, one part of the rock moves in an opposite direction of the other, pero parallel yung movement nila. Okay, it's in a parallel direction. So the most common example of yung parang pinaka-common and pinaka-sikat daw na pangyayari ng strike slip faulting is yung sa San Andreas Fault. Okay, yung nangyari na San Francisco earthquake in 1906. Okay, so isa yan sa pinaka sikat din na type ng earthquake as well as pinaka sikat na example ng strike slip faulting. Okay, so sa strike slip faulting, pwede daw malaman kung left or right yung displacement niya. So pag sinabing left lateral displacement, kapag daw nakaharap ka sa fault, okay? So nakaharap ka sa fault, kung titignan niyo yung figure dito, ito yung pinaka-fault, 'di ba? Yung paghahati sa gitna. Pag nakaharap ka diyan at yung movement ng rock na nasa harapan mo ay pa-left, yung movement ng rock na nasa harapan mo, okay, with respect to the fault, ay pa-left, left lateral displacement yon. Pero kapag nakaharap ka ulit sa fault, pero yung movement ng rock na nasa harapan mo, hindi yung tinatapakan mo, yung nasa harapan mo ay pa-right, right lateral displacement daw yon. Okay? Again, this is with respect to the actual fault. Okay? Kapag ikaw ay nakaharap sa fault at yung nasa harapan mong rock ay pa-left yung movement, left, lateral displacement. Kapag naman nakaharap ka ulit sa fault but the movement of the rock that is directly in front of you is pa-right, right lateral displacement. Okay? Okay. Next, so tapos na tayo sa brittle formations. Sa brittle formations, again, we have joints. Na-define lang natin kung ano yung joints. So, no movement between the two sides of the rock. Pag sinabi namang faults, may involve na movement or shifting on either side of the rock. Okay, madaming types ng faults. With respect to the direction of the movement, pag siya ay parallel to the dip slip. Pag siya naman ay parallel to the strike slip. Sa dip slip, may dalawang types, normal and reverse faults. Okay? We can differentiate them based on the type of stress. Kapag tension, siya ay normal. Kapag compression, siya ay reverse. We can also define them using kung ano yung effect niya sa crust. Kapag normal, siya ay usually accompanied by the lengthening of the crust. Kapag naman reverse, usually accompanied by the shortening of the crust. Kapag naman in terms of hanging wall block and foot wall block, kapag movement ng hanging wall block ay downwards, siya ay normal. Kapag naman ang movement ng hanging wall block ay upwards, siya ay reverse. Okay? So mag-move na tayo sa ductile deformation. So dito sa ductile deformations, ang usual na dinidiscuss dito is yung mga tinatawag nating mga folds. Okay? And again, pag ductile yung deformation niya, walang fragments na nagfo-form. Walang distinct parts na nagfo-form. So dito sa folds, usually it is the bending of the rocks. Okay? Yun yung change ng size and shape niya. Okay? Due to stress. Okay? Due to stress. When defining folds, usually, dinedefine din natin siya sa kanyang mga parts. Okay? So, okay. Isa-isay natin. Yung axial surface, etong hinge zone is basically yung point ng, ano niya, yung highest na, parang, paano ba natin siya i-define? Yung pinaka-highest na, kumbaga parang amplitude niya or yung highest na throw, ano ba yun, paano ba yung pronounce yan? Throw, yung sa pailalim. So, parang ganon. Yung highest na point niya doon sa amplitude or yung lowest. Yun yung hinge zone. Kung saan nagko-curve. Okay? Nagko-curve, kumbaga yung pinaka-fold natin. Okay? Yung axial surface is simply yung surface or ano ba dito, plane na naghahati doon sa hinge zone natin. Okay, naghahati doon sa hinge zone natin. Yung axial trace is yung line na parallel doon sa surface. Tapos yung limbs naman is basically yung pinaka ano niya talaga, pinaka parang curvature doon sa folds. Okay? So yun yung sa limbs natin. So may two types ng folds, syncline or anticline. Actually meron pa yan, monocline, isocline, ganun-ganon. But simply ito lang i-discuss natin yung syncline and anticline. So pag sinabing syncline, simply ito yung, para madali daw siya tandaan, sabi, yung syncline, kapag nagfo-form ng bottom ng S, okay, yung bottom ng S, parang ganyan yung general shape na fina-follow niya. For example, ito, parang pag ganyan, di ba? Bottom of an S. Ito yung S kunyari. So, ito lang i-consider natin na shape, yung baba niya lang na part. Syncline yon. Okay? Yung hinge zone niya nahanap sa baba, tas yung folds niya ay, kumbaga, away from the hinge zone. Away from the hinge zone. Yan. So, ganun yung syncline. While yung anticline, para daw madali tandaan, ito, mas madali talaga makita. Anticline, yung shape niya ay pa-A. Okay? Shape niya ay pa-A. Yung hinge zone niya nahanap dito sa taas, tas yung folds niya ay, kumbaga parang, yan, towards. Hindi pala. Ito yung away. Yung sa syncline pala yung towards the hinge zone. Ito yung away. Tapos ito yung towards the hinge zone. Okay, so pwedeng mag-occur siya independently, yung syncline at anticline. But as you can see here, most of them ay um, nahanap ng magkasama. Pwedeng series of synclines and anticlines. And pag series of synclines and anticlines, may tawag doon. Ang tawag doon ay fold deformations. Nakalimutan ko yung tawag, sorry. Fold formations, I think it's called fold formations. Okay, anyway, you can search that. Okay. Onti na lang. Sorry, mag-overtime ako ng onti. Ayan, dito, series of synclines and anticlines. Ito, right here, this is a syncline. Okay, bottom of an S. So, kung makikita nyo dito, itong pataas na to, this is an anticline. How about this one, guys? Anticline, syncline. Bilis, guys. Anticline, syncline. Itong part na to, this one here. This one, anong shape na form niya? Letter A, di ba? So this is very good, anticline. How about this one here, this part here? Syncline, anticline? Syncline, very good. How about this one here? Syncline. This one here, anticline. Okay? This one here, syncline. Very good. Okay, so mapapansin nyo, hindi pwede ding symmetrical siya or asymmetrical. Pwede po yun. Okay. Onti na lang po. Sorry na po. Okay, ito yung, may kailangan lang ako sagutin tanong, but after this recording na lang. So these are my resources. Si Marshak ulit, pero nadagdagan yung Essentials of Geology. Etong Lutgens daw yung usually mas gamit. Tapos ito, yung kay Panchuk na Physical Geology. Okay, so are there any questions? Let me just stop recording.